Hello everyone, welcome back to the series of Ekalavya EC Lab Experiments. I'm Vinay Kumar from Vaidya Technologies. In the previous episode, we saw how to demonstrate the projects, right from creating the project, creating the file, the Verilog file or the physical constraint file to assign the pins of the design onto the FPGA board. We also saw the process of compiling, synthesizing, and programming the Ekalavya board, then validating or verifying the design using Ekalavya board after the programming part. Uh, and we also saw how to extract the reports after synthesis part, be it synthesized report, a place and route report, timing analysis, or power analysis reports. And we also saw how to extract the RTL schematic design of the written designs. Uh, so in this episode, let us do the demonstration of the rest of the logic gates. That is basic gates such as AND and OR, then universal gates such as NAND and NOR, and finally we'll touch on exclusive gates, that is XOR and XNOR. So having that said, let's start, guys. So let me launch the Govin PG processor. Okay, I've already created the projects, written the code as well as the constraint file. Let us review the code and then compile it and program the same and verify the functionality of the code. So this is the AND gate. AND gate has two inputs, one output, and the no the Y is assigned to A and B. Physical constraint file, that is pin A, that is input A and B. A is assigned to 69th pin of the FPGA, and B is assigned to 68th pin of the FPGA. Y being the output is assigned to 136th pin of the FPGA. Here A and B is it's the switch 1 and switch 2 that is on the multi-shield board, and Y is the LED on the shield, Arduino multi-shield board. uh, okay, let me compile it, guys. Fine. Okay, that's done. You can access these reports here. Okay. Okay, let us program it. Okay, the programming part is done. Now this is the EC Lab manual provided by Vidya Technologies. This comes along with the Ekalavya board itself, so you guys can take this as a reference and move forward. So, and gate, let me flip my camera. So here's the Ekalavya board. I'll interface this with the Arduino multi-shield board. Okay. Here is our Ekalavya board, and the below board is our Ekalavya board, and the top one is the Arduino multi-shield. The top one is Arduino multi-shield board. Okay. It's not focusing properly. Okay, fine. So the AND gate says if all the inputs are high, then we get the output as high. If not, we get the output as 0. So here A and B are 0. Here the A, I have assigned A to the switch 1 and B to the switch 2, and the D4 LED here, which you can see, is the output, that is Y is assigned there. So A and B are 0, switches are not pressed, therefore the input, the values of it will be 0. Now I will press A, then I will give input A as 1, then let B be 0. Again I'm getting the output as 0. Now I will press B, giving input as 1, and A keeping it as 0. Again the output is 0. Now I'll give inputs to both A and B as 1, therefore the output should be 1, and that is been indicated by the LED being high. So that should validate our AND gate. Now let's quickly move on to OR gate. Okay. So here is our get. I've already written the code too. So A and B are the input, Y is the output, where Y is equal to A or B. Constraint file remains the same. Yeah, constraint file remains the same. Let me code it. I'm sorry, compile it. I don't know why it got terminated. Okay. Okay, fine. Okay, guys. Compilation, synthesis, and place and route is done. You can access the reports over here, and RTL schematics over here. Let me just quickly select it. This is your OR gate. Okay. So since we are compiled, let me program it. So the FLs file here is the file that has been generated after the synthesis. Uh, the code that you have written will be converted into the bit streams, and that is known as FS file here. And this FS file, the bit stream file, will be sent to the development boards, where you can where that reads and recognizes the bit stream and operates accordingly. So yeah. Now let's validate OR gate. So in OR gate, if either of the input is 1, or if both the inputs are 1, then the output will be 1. Else, if both the inputs are 0, then the output will be 0. So here again, switch 1 is A, switch 2 is B, and D4 is the output. So both inputs are 0, Y is 0. A is 1, B is 0, Y is 1. A is 0 and B is 1, Y will be 0. And if both the inputs are high, then Y will be high. So that validates our OR gate. Let me move on to the next logic gate. Let's go for NAND gate. Okay, again I've already written the code. Everything remains the same, only the assignment assignment statement changes. So NAND is nothing but not of AND gate, therefore the inversion part is here. That's the only change between this and AND gate. So pin constraint file remains the same, guys. I'll just compile it. Okay, let me program it quickly. Where are you? Selected. Okay. So here, yeah, as I said, NAND gate is not of AND gate, where um, we get the output as 0 when both the inputs are high, and we get output as 1 when uh, you know uh, any one of the input, any one or both the inputs are 0. So now A and B both are 0, therefore output is high, which where you can see A and B is 0, output here is 1, therefore LED is glowing. Let me make A as 1 and B be 0, again the output will be 1. Now let me make B is equal to 1 and let A be 0, again the output is 1. Now let me make both the inputs as 1 and the LED turns off. So that should validate the NAND gate. Let's move on to the NOR gate. Open. Okay. Okay. NOR is nothing but not of OR gate. Again, a inversion part will do the job. CST file remains the same. Let us compile. Arre. Okay. So compilation is done. Let me program our board and no, let's validate the functionality over there. Let me choose the file. You don't have to be going around to choose the file every time. Here, for the ease of process, I've created, no, I've moved all the FS files to a folder, to make this job, to make my recording job easy. So you don't have to be moving around um, every time. Okay. Which one did I? Okay. Upload.org. That is not. Okay. So OR gate says if both the inputs are 0, then the output will be 1, or otherwise the output will be 0. So here both A and B are 0, the output is 1 here. Let me make B is equal to 1 and let A be 0, output is 0. Let A be 1 and B is equal to 0, output will be 0. Let both the inputs be 1. You can see output is 0. So that validates our NOR gate. Now let's move on to our final section, that is XOR gate and XNOR gate. Let me quickly open the project. My system has got slow. XOR. Fine. So XNOR XOR gate. So this is the design. CST file remains the same. Let me compile it. Compilation is almost done. Let me program our Ekalavya. Okay. So as far XOR is concerned, if both the inputs are 0 or if both the inputs are 1, then the output should be 0. If either of the inputs is 1, then the output will be 1. So now both the inputs are 0, therefore the output is 0. If both the inputs are 1, then the output is 0. Now let me make any one input as 1, therefore output is 1. Now B1, so okay, the output is 1. So that validates our XOR gate. And for the final gate, let me quickly open XNOR. Okay, CSV file remains the same. Not of XOR is XNOR, guys. So everything remains the same, only not inversion symbol comes there. Compiled it. Okay, let me program. Select my FS file. XOR git programming complete. So for XNOR, if both the inputs are 0, then it will be 1, or if both the inputs are 1, then it will be 1. Otherwise, the output will be 0. As you can see, both the inputs are 0 over here, output is 1. Let me make both the inputs as 1. Now again, we are getting the output as 1. Now if I make any one of the inputs 1, which should turn off the LED, and it is doing it. That should validate our XNOR gate. So that's it, guys, for this episode. And in Eklavya IC lab, the the content goes like this. We are giving the aim, the required materials to conduct this experiment, which requires a Kalavya board itself and supporting software, that is Go EDA tool, a USB-C type cable to connect it with the laptop, and you can use the switches using breadboard, or you can use a multi-shield Arduino breakout boards like this in order to interface it and have your inputs given through it and validate the process. So this lab manual contains a brief introduction, required materials, aim, then the code itself, simulation waveform, the RTL design, and a conclusion of it. So for the next episode, let us look for the adders, that is half adder and the full adder. This is it for this video, guys. Thank you.